Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmidin bin Khairul Anwar. Today we'll discuss about my group assignment. Firstly, introduction. Consider a system of numerous forces acting at the same moment on the same object, each with a different direction and a multiply. The resultant force is the total all of those forces, depending on the direction of each force. The sum of all the force can be a difference. For a better understanding, let's look at some easy examples. When a skydiver jumps out of plane, two forces acting on him: the air drag force and the weight force F weight, which are dragging the skydiver forwards. The earth surface due to gravity. Fair drag opposites. The skydiver's passage drop the air and attempts to slow him down. As you can see, the weight and drag force are in opposite direction. Hence, the resultant force in the difference between them. Besides that, the resultant force is the final force acting on an item. After all, the component force operating on the body have been combined by vector addition. To put it another way, the resultant force is a single force that has the same effect on the body as two more simulation force. So here we go to background of case study. Based on the diagram above, we can see that in the construction we also use resultant force. The proof is that when the crane lifts a heavy load, they will hold the load like in the picture above, because it will facilitate the crane to lift heavy loads with balance. Among the other advantage of using this technique is that it does not damage the rope on the crane, because the load received by the rope is the same and the lift load does not rotate, because the resulting velocity is uniform.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azizul Hafiz bin Muhammad Azlan. Number matric is AA217094. I will present about basic theory or literature review. When two or more forces act on a body, the resultant force or net force is the sum of all the force then generate in the using effect. Because force is a vector, we must calculate the resultant by taking the vector sum of all the force. An appropriate combination of many forces operating on a body can result in a zero consecutive, which has no net effect. Generally, if F1 or F2 or F3 and each other are the force acting on a body, the resultant force is the given by F equals 4, 1 plus 4, 2 plus 4, 3 and each other. The consequence can be calculated geometrically using the triangle law, parallelogram law and polygon law, or vector addition. Depending on the number of force operating is worth nothing that useless. The force are collinear. They can be add or subtract illustrated. Analysis and calculation. Based on the above question, we need to find the angle to balance an object. Given F1 equals 125 Newton and theta 1 equals 45 and F2 equals 100 Newton. Assume that Fx equals 0. Equate Fx with the following solution path and we will get the answer by calculating the question. Finally, the angle to balance the object is 62.11 theta.
Nextly, for discussion, the resultant force is required to change the velocity of an object. If the resultant force is 0, the force on the object are balanced. If the resultant force acting on the object is 0, the object will remain stationary. In this case, the object will travel a straight line at a constant speed. Besides that, the importance of resulting force is useful because it allows us to consider several forces at Fd. This indicates that we just need to determine the influence of a single force, determine the effect of numerous forces on an object. Furthermore, this resultant force is available everywhere because the concept used is very simple. And in addition, there are many benefits if we use this principle. Among them, we can balance an object. An object will also be stronger when there is the help of resultant force. As example, electric poles can use this concept that electric poles can stand stably, especially large electric poles. This happens because the resulting force is 0. In addition, the resultant force is also important in the automotive field because with it we can lift a heavy load with balance. For example, in the port, there is a machine that lifts containers. The weight lifted by the machine looks balanced and does not turn around. Next, the car workshop also adopt this concept. The proof is when they hang the engine for cleaning purpose, and so here we can see they use the principle of resultant force to balance the engine position. In addition, the force balance is also relate to the resultant force. This force balance occurs if the resultant force is 0 when several forces act on an object. When a force equilibrium is reached, no net force act on the object. The object is either in the state of stationary or moving with uniform velocity. As a whole, it is proven that the resultant force plays a role in our lives because with this principle we can balance many objects on the earth because the resultant force is closely related to the force balance. As explained above, when the resultant force is 0, the velocity will also be 0, causing a power balance to result. Lastly, for the conclusion. In conclusion, if the resultant force acting on the object is 0, the object will remain stationary. The importance of resulting force is because it allows us to consider several forces as if they were all equal. 4 minutes, force is required to change the velocity of an object. In this case, the object travels at the constant speed. Besides that, the resultant force is available everywhere because the concept used is very simple. And in addition, there are many benefits if we use this principle. Among them, we can balance an object, and the object will also be stronger when there is help his resultant force. Finally, when numerous forces act on an object, the resultant force is created, and the resultant force balance is also connected to the force balance. A machine that lifts containers, for example, can be found in the pot. The weight raised by the machine appears to be evenly distributed and does not rotate. This is due to the fact that the resultant force is zero. When a force equilibrium is attained, there is not force acting on the object, and it is either stationary or moving at the uniform pace.